Chapter 23, Commercial Vehicle Tires, Video 2, Safety. A couple of different things we need to understand when we're the energy involved when we are working around tires to take that into account. So we're working safely around these tires is that because of the large amount of air pressure and surface area and volume of air that the tire has, it's a lot of stored energy, right? We use that in the compressed air holds a lot of energy within it. So when we're doing maintenance to the tire, assembling, disassembling, any kind of repairs around the wheels and tires, we need to be very conscious of the forces that can be released because of that trapped pressure. The tire, we're talking, we can go anywhere from 30,000 pounds of combined force in a passenger vehicle tire to several million pounds of force available in a super single tire, just because of the volume of air, the pressure, the surface area in there. The tires you've got a large safety factor built into them to be able to withstand all those forces. Same with the wheels and all the components. We just need to be aware of if we have a problem or doing some maintenance on the wheels and tires, that we respect that stored energy, and that we either de-energize it by deflating the tire or contain it with a tire cage or containment system. Another thing to note is, just like with the examples here in the diagram, is the way that force is expended from the tire if it does come loose is coming directly out or 45 degrees from the rupture. So if we're working around that, we take that in consideration with the placement of ourselves or how we position the tire, so that if we do have a problem, that we can avoid any kind of injury to ourselves or anybody else. So the working around the tire, again, the release of all that compressed air, just the energy itself, if it breaks a wheel or a tire or something like that, or some of the components, the debris that comes with that, just the release of the energy of that, take that into account. Inflating the tires is a very dangerous time. This is because we are building up that stored energy, and if we have any problems with the wheel, rupture in the tire or a fault in the tire, that's the most potential time for a technician to be hurt by that or have that energy released. If we have some broken components or some damaged components or weak components when we're inflating that tire, is a time that we need to be especially careful. Again, the wheels and tires with factory made or assembled, they're well within their capacity to handle all those forces. The problem now becomes if they've been modified or damaged, improperly assembled, something like that. We don't have the proper components going back onto that. They're not matched to what they should be. That's a dangerous time. And so, part of that becomes when we're doing our inspections to find those faults that were the potential there to release that energy. So make sure we're doing a thorough investigation of that wheel and tire. So there's certain regulations with the wheels and tires, and again, that's more of a manufacturing time that when those are manufactured to a certain levels of safety. We just need to make sure that we're using the proper wheel matched to the proper tire as far as a technician working around these wheels and tires. A couple things we want to make sure that we do not mix tires on the same axle, radial tires or bi-supply tires. So if we've got the rear drive axle on the driver's side has got radial tires, and then the same axle on the passenger side has got it's the opposite. We've got bi-supply tires. We have a mixture. The way that those accept load and the how the tire deforms when load's put on it is completely different. So we don't mix radial tires, especially side by side or on the same axle. So if we've got radial tires on the driver's side, we would like to have radial tires on the passenger side also. And same starts to play true when we've got a dual drive system. All four of those drive wheel ends should have the same makeup of the tires, all radial, excuse me, all radial or all bi-supply tires, so that they all respond to the way the load is put on and how they react to that load, so that we don't cause any problems. With one tire loading more, can cause it to overheat and then become damaged. So again, we want to make sure they're the same make, and then tread design. That also affects how they carry the weight and how they transfer that traction through to the axles, to the through the wheels, and then to the pavement. So we want to make sure that we have all those are all common. So all radial, all of the same traction design. So I talked about the tire pressure being the biggest factor of the maintenance of the tires. So they do have tire pressure monitoring systems, or TPMSs, that will monitor that, lets the operator know that we've got a tire that's going low, so that he can make that correction, either adding the air or investigating to find out why it's losing air. If we've got a slow leak, we've picked up a nail or a screw, and that tire's got a leak in it, continuing to affect that. Affects the load carrying capacity of that dual. Its partner right beside it could be carrying more of the load, and now we've just overloaded that tire and caused for potential for damage to that. Getting more into the efficiency of the tire at its proper inflation. Again, helps with increase the efficiency of the overall efficiency of the truck, and again, better mileage, lower emissions, extending that tire life.